Hello and welcome to the new series of Drishti IAS. I am Pooja Devedi, and in this segment today, we are going to discuss about the concern with respect to the new variant of COVID-19, the Omicron variant. This topic is important from the perspective of prelims and mains, and also very important to raise awareness about the new concerns with respect to this new variant, because we all are touched with respect to this COVID-19, the second wave we were touched. Each of us might have some family member, might have someone in a relation or a distant relative who have been affected by or who has been affected by the COVID-19 second wave. So be very cautious when we talk about the reasons why we need to be so watchful of this new variant, and also from the general populace. Okay, so let's begin with different topics that we are going to discuss. These are the many topics, and mutation, why they occur, how they occur, everything is going to be talked about in brief. And as you can see, this new variant recently has been named Omicron. Omicron variant, this is a variant of concern. We will discuss about everything. So don't be worried why is she using this terminology and not explaining right now, because I will explain it in the later stages. And this new variant is causing a lot of concern not only to the European nations but India as well, because India has recently conducted one high-level meeting and it was chaired by none other than the Prime Minister. That means the vigilance needs to be high, as we are having a lot of problems with respect to the second wave of the COVID-19 pandemic, as we remember how horrendous the situation and harrowing the situation was, and how we ran out of beds, oxygen beds at hospitals. There was nothing, no preparation was done when we talk about the second wave of the COVID-19 pandemic. So India wants to be ready for, might be, God forbid, the next coming wave. Let's move forward and talk about that. What is mutation basically? Mutation means the changing of the nature. The fundamentals might remain same, but there has to be a change in the nature of the spike protein makeup so that it can be termed as mutation. In layman's term, I told you that. And in scientific terms, it means alteration to the genetic material. The genetic material has changed of the genome of a cell. So as we know that all the information of any living organism is either in the DNA or RNA. DNA, as you can see, it's a short form for deoxyribonucleic acid. And this stores the entire information about our genetic material. So this is how the structure of DNA is. And RNA is a single-stranded nucleic acid. It is known as ribonucleic acid. So our COVID-19 or SARS-CoV-2 is a RNA virus. And there is an importance with respect to mutation and how we will discuss about that as well. So any information that has been stored in the DNA, if it changes or alters and is more or less permanent in nature so that it can pass on to the descendants of the virus, is known as mutation. And it can be transmitted to the cells or the virus descendants. This is what I've told you already. So basically, if we told you that how does it happen, you will be able to understand that viruses do mutate every now and then. There is this is not any kind of surprise that how do these mutations occur. The problem is that heavy mutations have happened. 50 plus mutations have happened. The Delta variant was a double mutant. This variant has 50 mutations. That means it has passed on from a lot of people. So that is why it is able to store so much information. As it is an RNA, it can store a lot of information better than the DNA. And viruses, they have a genetic code. This is the form of nucleic acid. And whenever the cells multiply, the DNA also replicates. Like whenever multiplication happens, DNA will also start on replicating. And also the new copies of the cells will be made. Whenever the new copies of the cells will be made, the virus will also have problems with the creation of the exact same copy. So whenever it multiplies, there can be random errors, and that is introduced into the new DNA. The thing we need to understand over here, that the problems or errors in the DNA can be corrected by the DNA, and because of correction, mutations do not occur in DNA. But RNA, it doesn't correct the mutation, it doesn't correct the errors. So what happens? It accumulates all information, and that is why mutations start to happen. So correction can be done in DNA, mutations don't happen, but corrections can't be done and accumulation of information is done in the RNA. So that is why mutations occur. And RNA viruses accumulate more genetic changes, and that is why we have our new mutated virus. Moving on. Why does it happen? Because it has passed on from a group of people. One person might be highly immunocompromised, and that is why so many mutations have occurred. Let's move forward and talk about the worry. Do we need to worry about the mutations? See, mutations might make a virus stronger or weaker, but mutations become a concern when they abandon their original copy and selectively multiply to a better copy. Mutations does not always mean division. That means division is there, but it is also selective in nature, in the sense that whenever any kind of virus is going to be selective in terms of transmissibility, vaccine evasion, that means it can evade the immunity and also can cause severe disease. If it finds that now I am a virus, suppose, and I think that this new copy is much more infective in nature, can transmit at a higher rate, can cause more severe disease, and I can also bypass this person's immune system, then I will abandon my parent virus, abandon my parent material, and I will become a new virus. And that is the entire concern. Right now, not a lot of research has been done with respect to what are the new symptoms, because mutations, whenever they occur, they also cause new symptoms to occur. So this is the one thing, then more research is needed right now. So receptor binding domain of the spike protein have the most potential to evade the antibodies. Antibodies either can be vaccine elicited or natural infection elicited. So how the problem arises here, as you can see, this is the virus A or the parent virus, okay, and it has these spike proteins. So these antibodies, the white one antibodies, they recognize this shape of spike. So whenever we introduce antibodies into our system, either through vaccine or natural infection, this stick to it, okay, the spike proteins, and they will destroy these virus cells. When there will be a mutation, here the mutation has occurred, so the spike protein has also changed its shape. The antibodies which were previously there to understand and recognize the same infection will not be able to recognize this spike protein. So these antibodies, either through vaccine or natural infection, cannot recognize it, and hence this is much more efficient than the previous infection or the previous virus. So this is the entire issue. Are vaccines going to be effective? We do not know as of yet. Okay, and the RBD binds the cellular receptor, allowing the virus to infect the cell. That means this is the spike protein and this is the cell. Through this only it can get into the cell. So we need to, in order to pacify a virus, we need to get rid of the spike proteins. The new virus has 32 minimum, I am that saying, 32 mutations when we talk about spike virus. So it becomes very hard for the already infected person and already vaccinated person to be assured of the fact that they are safe. Let's move forward and talk about one kind of, this might be a hypothesis, that the new COVID variant, which is named B.1.1529, this is the name of the Omicron. So Omicron might have mutated from an AIDS infected person. Okay, And that is why, this is a hypothesis why I'm saying that, because this virus has so many mutations, this has to have passed through a person who has highly immunocompromised system. People who have HIV have their immune system compromised. So it can be possible. Let's move forward and talk about the new variant. This variant was the first ever known infection that came from a specimen that was collected on 9th of November, and it was first reported to the WHO from South Africa on 24th of November. And only about 24% of the South Africa's population is fully vaccinated, and that might be one of the reasons that the unvaccinated people were a part of the problem. Also, if we talk about the surge in the number of cases in South Africa, it coincided with the discovery of this new variant. There has been a rise in the rise of fourfold increase has been seen in the number of cases when this variant was seen in Africa. So it has also went to many other countries. We will discuss about that as well. And variant of interest and variant of concern are two different things. Variant of interest might be a variant which is new in nature, but it is not as severe as the previous one. And variant of concern is something that has the potential of being severe. So there are three criteria. First, astounding collection of mutation is there. Before getting through the criteria, I would like to tell you about the problem with this virus. As I have already said that here we have written 30 mutations, but recently a news has come, it has minimum 50 mutations and 32 in spike proteins. There is a possibility that more research is done and more mutations can be seen. So it has a constellation of mutations and it has faster transmissibility. First criteria is fulfilled for becoming a variant of concern, that it is able to affect or infect people at a much higher rate or faster rate. That is much more than the Delta variant, which brought the entire world and especially India on its heels. Second, it has the capability to evade the immune system. Several patients who were infected, they had been vaccinated fully. That means they received the 2 doses. And one of them was even somebody who also received a booster dose. That means 2 vaccines plus the third. So it can evade. But these 2 mutations we have to remember are because of the 2 main reasons, main 2 mutations, R23K and R24R. It helps the virus to replicate faster. And 3 of these mutations are H655Y, HN679K and P681H. It helps the virus to sneak into the immune system. So whether you are vaccinated or unvaccinated, whether you have been previously infected or not, it doesn't matter. You are all the same in front of the virus. Also, the third criteria is the ability to cause severe disease such as hospitalization or death. As of yet, luckily, we have not seen such instances. More research is to be done. Let's move forward and talk about where it has spread. So it has spread to many countries. Not a lot, but cases have been reported in Hong Kong, in Belgium, in Israel. Recently, a news was there that in Netherlands, 61 travelers who were coming back from South Africa, they were found to be infected. Although what kind of variant they are carrying, we do not know yet. But it's going to be there for genome sequencing, and then only we will be able to know what variant they are carrying. And 2 confirmed cases have been reported in Hong Kong, and 1 each in Israel and Belgium. And 3 others are suspected to be carrying the strain in Israel. The contacts, of course. And Japan, as a reaction, has already said that from Saturday, travelers from much of the South African countries will need to quarantine for 10 days. Again, it's very good that vigilance is there. And take a total of 4 tests that time. And Iran will ban travelers from 6 southern African countries. Iran will ban altogether because Iran was one of the countries which were one of the most affected from the COVID-19 waves. That is from Iranians arriving from the regions, they will be admitted after testing negative twice. Also, Brazil has said that it was restricting travel from 6 countries of Africa. Although the WHO has said that this is against the norms of the WHO itself, the guidelines, we cannot impose ban all of a sudden without any scientific basis, but still the fear looms large. Moving on, let's talk about the vaccines. Are they effective or not? First, we need to understand that this particular Omicron variant has the ability also to evade the testing system, especially RT-PCR. RT-PCR, because there has been a deletion, as I told you, mutation will cause some changes. So there has been a deletion in the gene S of the virus. It has been deleted. Now, gene S would have helped the variant to be recognized by RT-PCR. But the good thing is that gene N and RPRD, these two genes are not deleted. So it might happen that once the virus can evade the RT-PCR, but if we do it 2 to 3 to 4 times, it might happen that it gets detected. So that is why so many tests are needed for RT-PCR, like 4 times, 2 times, 3 times, like that. Okay. So first is that it can evade. Second, that mutations have occurred and the spike protein might have changed. Of course, it has changed. So the antibodies are able to recognize them or not, we do not know yet. But the rate of infection in vaccinated people does show that it can evade the barriers. But we also need to understand that South African population is not that vaccinated. 24% of the population is only vaccinated. So that is a cause of concern. Also, Omicron's epidemiological and clinical correlation is not fully established because not a lot of research has been done. The good thing is that continuous genome sequencing has helped the countries to understand the new variations. Also, many vaccine companies, they have, of course, they have gotten into the rush of developing new vaccines. Another good thing is that we already have certain data with respect to the causality of this particular variation. So we will be able to know what kind of changes do we need in our vaccination program. Also, as scientists, we need a more scientific approach towards having a third dose or not. So as of right now, the best possible solution is please wear masks, please follow COVID-19 protocols, physical distancing. All that is very needed because we do not know. Viruses are very secretive in nature. They are very clandestine in nature. So we need to know that what best is possible for us is to have COVID-19 protocols happening. Moving on, let's talk about India and Omicron. What is the status of it? Right now, as of now, there has been no case reported, but a high-level meeting has been there chaired by the Prime Minister of India, and a decision has been taken that each person entering Mumbai from South Africa to be quarantined on arrival, samples to be sent for genome sequencing if they are positive. First is that. Secondly, there has been a vigilance and testing for travelers coming from Belgium as well, and also Hong Kong, Israel. Might be possible that if the cases are surging in Netherlands also. So there are still 12 risk countries which India is planning to have a stricter vigilance upon when from the 15th of December we are going to have our commercial international flights going on. Let's move on and talk about the conclusion. It's a bad news but not doomsday. Heavily mutated, unusual constellation, faster transmissibility, these all make it a bad news. But it's not a doomsday right now because it's not causing death or severe hospitalization as of yet. It's like a storm in a teacup, as the WHO has said. Genome sequencing is the best possible solution when we talk about having knowledge about the symptoms, because as of yet, not a lot of changes in the symptoms have occurred. It's the same fever and coughing and everything else that has been related to the previous viruses. Many of them are also asymptomatic. But in order to understand how it may get into the pockets of the immunocompromised people, it is important to have genome sequencing. And COVID-appropriate behavior, as I told you, we need to follow. There is no shortcut for it. Also, testing, constant testing, especially in states which have open boundaries, which share a boundary with many states, such as Uttar Pradesh, such as Madhya Pradesh, such as Chhattisgarh, such as Maharashtra, especially with the states which are receiving a lot of foreign travelers, it needs to be done. Vaccination, as I told you, India is saved as of yet because it has a high percentage of vaccination. South Africa and other countries, even Germany, does not have that of a high of vaccination. Vaccination remains critical and vaccination should be undertaken in many countries because none of us are safe until and unless all of us are safe. So all the countries should come together to understand the importance of getting vaccines into the poorer countries, especially in the countries of Africa. So that's it. Let's move on to our mains-based question. What is mutation in a virus? Discuss in detail about mutation in the light of the new Omicron variant of SARS-CoV-2. So that's it for today. Tomorrow we shall meet again with another segment. Until then, stay updated and thank you so much for watching.